Hi, welcome to another video on the Learn LLM series. So instead of making a long video, we'll address small components so that there is complete clarity in understanding those foundational components, basic components. So today's topic is softmax. What is its significance? Welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we bring you hands-on demonstrations and insights into the latest tools and trends to help you get started with ease. Don't forget to subscribe and be a part of our journey into the future of technology. And I have made a simple web interface which you can also play with it to see how it works. So before we look at the visualizer, let's understand the sub-elements of softmax. First, we need to understand what are logits. Logits are raw output scores from the model's final layer before applying any transformation. It is neither 0, neither 1, and not even probabilistic. So they represent unnormalized confidence level. So softmax transforms logits, that is unnormalized values, to probabilities. Always remember, and it adds up to 1. So that is 100%. So multiple outputs of the model, depending on the dimension, will generate logits, and when put through softmax, it will give you the probability. It allows the model to express confidence for each class in a probabilistic way. So when it comes to next word generation, for example, it will give you the probability of those words. It's calculated by dividing the exponentiated value of one output divided by the total of those values. So that gives us the valid probabilities. And why normalize? Normalization ensures that the outputs are meaningful probability, helping models to make interpretable and fair decisions. This also helps in numerical stability to avoid overflow, underflow from large exponentials. And what is numerical stability? To avoid overflow and underflow from large exponential, we subtract the maximum logit before computing softmax. So this doesn't change the result but prevents errors. So always compute softmax as exponential of logit value minus max logits. So softmax is a function that converts a list of numbers, logits, into a probability distribution. It is widely used in classification problems and attention mechanism neural network. Okay, so here is examples that I have added. For example, inputs 2, 1 and 0.1. The softmax outputs roughly 0.65, 0.22, 0.24 and 0.11, and they add up to 1. Key properties of softmax: output always adds up to 1, and that is a requirement for any probabilistic interpretation. It also has an amplification mechanism built in, that is, small absolute difference become large probability difference. We'll see that. So example 3 values 10, 9, 9 can become 0.84 and 0.08 and 0. See, 10 has become 0.84 and 9 has become 0.08. So it amplifies the difference. And temperature scaling, you can control the sharpness of softmax with the temperature parameter. Low temperature, sharper, more confident probabilities. High temperature, softer, more spread out probabilities. And when to use softmax? Multi-class classification, final layer in deep neural network, and attention mechanism in transformer. So we will see those things also like this bit by bit. Common mistake: manual softmax before cross entropy loss. So one thing we need to remember is softmax and cross entropy loss functions, because cross entropy loss function need probability as its input. So it needs the labels and the probability. We'll see in the next video. We need to anyway use softmax. We should check if our libraries are implicitly using softmax. For example, PyTorch internally applies softmax. We shouldn't do manually softmax on top of it. It will distort the learning process. Okay, so here all the logits are 0. Okay, so let's make this say 1 and make this 0.1. Let's see what happens. See, the 1 has become around 40%. And remaining are in this range of 14-15%. So see this, the amplification can be clearly seen. So if this is, say, this is 3 and this one we make it 1, and you see this one, so I'm making all these 1. See this? See, this is 1.8, rest of the values are 1. And you see the 1.8 is distinctly amplified. I hope you won't forget what softmax is. So whenever you want to convert logics, whenever you want to convert raw outputs of deep neural network, probabilistically classified values, we will need softmax. This URL is given in the description. You can play with it and understand softmax well. Like this, small bit by bit, we will continue our journey in learning and understanding transformer architecture and LLMs inside out. So thank you for your time. Please remember to like, share and subscribe. See you in the next video. Bye-bye.